Hi all. So this video is about 9-volt batteries, specifically the rechargeable lithium ion types. We'll take a close look at the internals of a typical rechargeable 9-volt battery and conduct some tests to evaluate the actual energy capacity. So we are all familiar with alkaline 9-volt batteries, commonly used in smoke alarms and many other consumer gadgets. We now have rechargeable ones available in the same form factor. This is very convenient and also provides tremendous cost-saving opportunities. These rechargeable batteries have a long shelf life and can support more than 1,000 charge cycles. Being the same form factor as a traditional alkaline cell is tremendous, as no special handling is required during replacement. Let's take a quick peek inside a typical rechargeable 9-volt battery. The parts inside are a lithium ion cell. This is where energy is stored and discharged from. A battery management circuit. This manages safely recharging and discharging of the lithium ion cell. A housing that provides same form factor and connectivity as a traditional alkaline 9-volt cell, and also some protection from its rigid structure. Let's take a closer look at the battery management circuit. It's an elegant design that divides the functional parts into two portions. A portion that provides USB connectivity and manages voltage conversions and monitors lithium-ion cell charging and protection. And another portion that manages DC to DC boost conversion required for 9-volt output. It also provides protection from overcurrent draw and is typically vendor specific, but it's usually in the range of 0.5 to 1 amp. I have tested offerings from many vendors, and I can frankly state that when it comes to battery capacity, there's a lot of outright misrepresentation going on in this space. All rechargeable 9-volt cells I tested failed in their capacity claim, and I would love to hear from the viewers if they have any recommendations. My test setup is very straightforward. I use a high let-go battery analyzer for monitoring battery capacity. I set the trigger to 7 volts. That is, the cycle stops when the voltage drops below 7 volts. For a resistive load, instead of using a boring resistance, I connected 4 small motors in parallel. Yeah, the uplift is not sufficient to take flight, but at least I get some air circulation while the test is running. And the current draw is a near steady 0.18 amps. I tested various brands available at Amazon, and the links are in the description. The best performing brand was Qsmo, which averaged 430 milliamp hours at 9 volt, so about 3.8 watt hour capacity. The worst performing brand was EBL, and it was a terrible disappointment since they claimed 5.6 watt hour capacity. They average about 200 milliamp hours and only deliver at 8-ish volts for about 1.6 watt hour capacity. So I don't understand the need for this blatant misrepresentation, as it hurts the entire space. The typical capacity claim falsehood is something like this: 9 volt 1300 milliamp hour capacity. This would imply over 11 watt hour capacity, while in reality it's 1300 milliamp hour at actual cell, which is inside 3.7 volts. After boost conversion efficiency losses, one would be lucky to get 4 watt hour usable capacity. So despite the exaggerated capacity claims, 9-volt rechargeable cells are a big boost in helping consumers transition away from single-use batteries. In addition to the many positives from recharge capabilities, they also provide almost constant 9 volts. Also, lithium-ion safety has improved tremendously with better chemistry, example lithium iron phosphate, and better manufacturing quality control. So I am a big fan of long-living products. It's essential in our quest to reduce our carbon footprint. I also appreciate that it requires purposeful engineering to achieve long-living products. It doesn't matter whether we're building phones, cars, or common user gadgets. While software upgrades allow new features to be added over time, thus extending usefulness of a product, battery replacement is often a big impediment. I'm making specific design choices to allow user battery service options in our products. This means that when the battery charge cycle is near exhaustion, typically after many years, a user can replace the battery and continue using the product. Thank you for tuning in.